Some metals are more reactive than others, and boy does it cover a wide range, right? The bling metals such as gold don't even tend to get rusty. They tend to stay nice and shiny. They don't react with acids, they don't react with bases. You take a chunk of sodium, and perhaps many of you have seen this, and it'll react violently, even explosively, simply with water. It'll oxidize to form sodium oxide in a matter of seconds when you slice it in half. So an activity series is useful for metals. Now this is AP Chemistry, and it's all about what's on the test. So the most important question for this is, what do I have to know? And believe me, there's plenty of students who are forced to memorize entire lists such as this one here. But after consulting online and talking to various teachers, I am convinced that you do not have to memorize such tables. But you should know the general reactivities of each group, right? It's a handy thing to know. I don't know what kind of question would come out of it, but it's a nice practical thing. And given a table, you should be able to understand it. So the group ones can react just with water, right? That's worth knowing. The alkali metals react with water, boom, violently. Some of the group 2s do, and I don't know if you really need to know that it's calcium and barium that are considered to react with cold water. As you heat up the water, even some of the group 3s and a few of the transition metals can react. And this surprises me. According to this, if you take some aluminum foil and you throw it in boiling water, it will make hydrogen gas. Really? Boiling water? Wait a minute. Pots are made out of aluminum, things like this. I think what protects them as usual is that an aluminum pot or aluminum foil will very quickly form aluminum oxide. And so it's the aluminum oxide which is stable to these things. But pure aluminum will react with it, as will pure iron. As you get into some of the more central transition metals, they can react with acids. Maybe it doesn't surprise you that tin can react with acids. Lead can react with acids. Doesn't really surprise me. And finally, when you get to the bling metals, copper and silver and platinum, things like that, they're far more inert. And they're used for electrical leads. You have the gold-plated leads for your speaker cables because they're better. They don't get rusty, things like that. So just know those general trends. And that's what a general hydrogen displacement reaction looks like. And if you were asked, given a table, which one's more likely to react? Well, calcium does react with water. Look at that. But lead does not, right? So this is really pretty simple question. So you could say it looks like the calcium that's more likely to react. And that's a little bit about the activity series of metals.